Methods I will discuss in this video should not be taken seriously because they work in very few cases with no surety of correct answer. I made this video just for fun. You watch it just for fun. In short, viewers' discretion is advised. So having put this disclaimer out there, let's start right away with this CAT question. Pause and go through the question first and then proceed. Radius of this bigger circle is given to us and radius of this smaller circle is asked. We will solve this question by what I call as paper hack, in which we use a piece of paper to calculate ratio of lengths. There are two important criteria for paper hack. Firstly, options need to be far apart. Okay, options need to be far apart. And secondly, there should not be much rule of exact lengths in the question. Either ratio of lengths of the two line segments is asked, or even if exact length is given in the question, all other values should change in proportion to the given length. Like in this question, if this outer circle gets bigger, this inner circle will also get big in same proportion. That means ratio of radius of outer circle to that of radius of inner circle is going to remain same. So let's proceed with paper hack. We will take a piece of paper and we'll put it across this diameter of bigger circle. And when you place the paper on computer screen, you will be able to see through the paper because of the screen's illumination. Now mark the length of diameter of this bigger circle on this paper. Okay. From this corner of the paper till here is the diameter of bigger circle. Once you have marked the diameter, remove the paper from computer screen and half fold the paper till this mark. Okay, don't fold the complete paper, just fold it till this mark. Fold from here till here. Okay. Now half fold the paper a second time till this mark only. Half fold it. And just repeatedly fold it as many times it is comfortably possible. Once you have folded it 2 to 3 times, now start unfolding the paper. Okay. When you open the paper, you will be able to spot creases formed due to folding of the paper. Okay. This mark here was for diameter. Diameter is 4 units. Diameter of outer circle is 4 units. This middle crease must be the radius of the circle. This total is 4 units. That means halfway through should be 2 units. And halfway till 2 units, here this middle crease will be 1 unit. And half of 1 unit will be this crease representing 0.5 units. Now that you have turned your paper into a scale, you have turned your paper into a ruler, you can now put it on diameter of this smaller circle. Okay, we can put it across diameter of this smaller circle and we'll mark the diameter on this paper. Okay, till here, from this corner till here is the diameter of this smaller circle, and it is approximately between 0.5 and 1. We can say it is approximately 0.75 units, right? So radius of this smaller circle will be half of the diameter. That would be 0.75 upon 2. This is approximately equal to 0.37 units. Now let's check which one of these 4 given options fall close to 0.37 unit. Root 2 is approximately 1.4 units. 2 into 1.4 is 2.8. 3 minus 2.8 is 0.2 units. And B, option B is 4 minus 2.8 is 1.2 units. Option C is 7 minus 5.6, that is 1.4 units. Option D is 6 minus 5.6 is around 0.4 units, which would be our correct answer. If I had taken root 2 as 1.414 instead of 1.4, this value will be little more than 5.6, and 6 minus little more than 5.6 will give me little less than 0.4. it will give me a value very close to 0.37. So option D is the correct answer. This is how you use a piece of paper to compare two lengths. Crazy, right? But not crazier than what you would appear doing this in the exam hall. Anyway, we can also use paper to measure angles. Once again, we have a CAT question here, CAT 2004 question. I know it's an easy question, but just focus on the hack. Focus on the paper hack. Go through the question. Now here, actual lengths are not involved. So no matter how big or small this figure is drawn, angle DEC, which is asked from us, this angle will come out as same till this angle is 65 degrees and ED is parallel to diameter AC. So we are getting a definite value of angle DEC. Out of these four values, there will be a definite value of angle DEC, which is going to remain same no matter how this figure is drawn, how big or small this figure is drawn, following these constraints that this angle has to be 65 degrees and ED should be parallel to diameter AC. So if we can somehow verify that this angle is actually 65 degree, then we can be sure that this figure is drawn to scale and it is an actual representation of the question statement. Okay, because sometimes figures are simply there to give you an idea of what's going on. They are not drawn to actual measures. So how to measure this angle? How do we measure this angle? Step 1, take a piece of paper. Step 2, tear off its corner. Now fold this corner in such a way that this edge overlaps over this edge. Okay, this edge converges over this edge. Fold it. Similarly, fold it again such that this edge converges over this edge now. Okay, fold it again and again. Once you have folded it 2 to 3 times, now unfold this paper. And as you must have guessed by now that these creases denote different angles. Okay, this over here is a 0 degree angle and here we have a 90 degree angle. This middle crease between 0 degree and 90 degree will represent 45 degrees. Midway between 0 and 45 degree is this crease which will represent half of 45 degree, that is 22.5 degree. And half of 22.5 degree will be this crease representing 11.25 degree. That means each of these individual sectors will represent 11.25 degree. Okay, so this crease will represent 22.5 plus 11.25, that is 33.75 degree. And this line here will represent an angle between 45 degree and 90 degree. Okay, average of 45 degree and 90 degree is 67.5 degree. And ladies and gentlemen, we have a working protractor with us. Now check if this angle is what it says it is. Check if this angle CBE is 65 degrees or not. Then only we will be sure that this figure is drawn to actual measures. Okay, for that, to check this angle, we will overlap the 0 degree edge with this line BC and we'll put the corner of the protractor over point B. You will be able to see through the paper because of the screen's illumination. Okay, now this line BE is at 67.5 degrees. Okay, this line BE is at 67.5 degree. In fact, it is slightly lesser than 67.5 degree. That verifies this data that angle CBE is 65 degrees. Okay, it is very close to 67.5 degree. This angle CBE is 65 degrees. That means this figure is accurate, and now we can calculate angle DEC using this protractor. So place this handmade protractor overlapping its one edge on ED and its corner should overlap on this point E. Corner should overlap this point E. Now look out for this line EC. If this crease here, this line here represents 0 degree, then this line will be at 11.25 degrees and this line here will represent 22.5 degrees. Okay, and this EC is very close to 22.5. In fact, it is slightly above 22.5. It is very close to 22.5. So we can safely mark option D as the correct answer. Option D is our answer. So my initial advice will be my final advice. This video was just for fun and to tell you that these kinds of hacks are also sometimes very rarely possible. In case there was an option E as 23 degrees, and then in that case we would have wasted a hell lot of time going by this method. I hope you had fun watching this video. In case you have any queries regarding this method, keep them to yourself. Thank you.